Okay, let's get into this. So, I don't know what page it is in your notes, but we left off at the definition of the principal square root of a negative number. So if a is a positive number, the principal, so the principal square root of the negative number, negative a, is defined as the square root of negative a is the square root of a times I. Okay. And so if we look at this example 7, write negative 6 times negative 2 in standard form. Well, let's look at this. This is multiplication, right? So I'll write them separately. But that rule that I talked about in the last video goes both ways. So this, since it's multiplication, equals negative 6 times negative 2. Well, that equals what? The square root of 12. Which equals, we can break that down, factor that into 4 times 3, so that's 2 root 3, right? It asks us to write in standard form, right? So how would we write it? 2 square root of 3 plus 0i. Okay, let's look at 8. Simplify 4i squared and write in standard form. So 4i squared, that's 4 times negative 1, right? And then when it comes to the I cubed, think about what it means to what does the exponent mean, right? It's repeated multiplication. So I cubed is really I times I times I. Well, we know that I squared is negative 1, right? So if we want, we can rewrite this as negative 4 minus 2i squared times I, right? If I put those to multiply just those two. And then since I squared is negative 1, so that becomes negative 1 times I. So our final answer is negative 4 plus 2i, which is in standard form. All right. So two numbers of the form are called, Oh, this is just repeated. We already did that. Oh, I don't know why I'm repeating stuff. Okay. So we're actually almost done sooner than I thought. Okay. Use the quadratic formula to solve. And this problem is actually needs to be changed. So let's just change this slightly to 4x squared plus 15. I'm just changing the 15 and the 16. It's 15x plus 16. Equals 0. Okay. Now you tell me what's A, B, and C. A is good. 4. B is 15, right? And C is 16. Okay. I want you to, let's remember what's the quadratic formula. X equals what? Negative B plus or minus the square root of B squared minus 4AC all over 2A. So pause the video and set up your quadratic formula. Okay, so hopefully you've gotten this far and you got up to here, right? So let's go further because we have to, I want to take a look at something. Square root of 31, you can't factor that. 31 is prime, I believe. And so you can't factor that into perfect squares. So, but we can separate this into, so it's negative 15 over 8 plus the square root of 31i. And hopefully you saw how I got the square root of 31i. All I did was rewrite this. Oh, that yellow, it does not show well. All I did was rewrite this as 31 times negative 1, square root of 31 times negative 1. And since that's multiplication, I broke that up into 31 times the square root of negative 1. And the square root of negative 1 is just I, so that's how I got 31i. Okay? And so over 8. And then also x equals negative 15 over 8. Because remember, with the quadratic formula, it can give you up to 2 solutions, right? And so it does here. And here's the thing. If you notice, it should look familiar because this is the number. This number is the complex conjugate of this number. And in fact, and this is, we're almost done actually. I'll end with this. Well, I got to talk about the bonus problem in a minute, but I'll end with this. Make sure you write this down. When you have a complex solution in your final answer. So when you have a complex solution in your final answer, its conjugate will also be a solution. And let me tell you why I really like this. Besides the fact I really love math. You get 2 for the price of 1. Like, who doesn't like to go to the store and it's buy 1, get 1 free, right? So you get 2 for the price of 1 with this complex solution. So whenever if someone tells you that this complex solution is a zero or root of a polynomial, then you automatically know it's conjugate. They come in pairs. They cannot be separated. If a complex conjugate, a complex solution is part of your answer, its conjugate is also a solution. And that's beautiful. I love that 2 for 1 deal. All right. So the last thing I want to leave you with is this bonus problem, which will be worth, I don't know, either it's going to be worth something if you do it. It's either going to be worth something on the exam or on this quiz. I'm not for sure yet. But I want to see if you can just sort of think how this section it was a lot of computation and pretty straightforward computation. So I wanted to see if you can sort of take that computational level to a higher level. And let me just say a couple things. So the bonus problem is asking you to prove that the complex conjugate of the product of 2 complex numbers, and they give you 2 complex numbers here, is the product of their complex conjugate. So the complex conjugate of the product. So basically, once you find the product of your 2 complex numbers, find that conjugate, and that conjugate is going to be the product of their complex. It's equal to the product of the complex conjugates. Okay. It's a lot of conjugates going on and complex going on. But I want to see how you interpret this. So bring this to class on Monday. I'm not even going to just hand it in. I'm not even going to ask for it. Hand it in, and I'll let you guys know what is going to be worth, either some values on the quiz or value on the exam. All right, this is the end of the video.